Now we shall be discussing about the magnetic field due to a straight conductor. Right? So straight conductor means that this conductor is straight and it is carrying the current. As in the previous lecture we have discussed that for a small part of L known as GL, the magnitude of the magnetic field that is being found out for the expression as mu naught divided by 4 pi multiplied by I, the amount of the current, multiplied by dl, or the length for which we are observing, the length of the conductor, multiplied with the sine of the angle of or between the separation of that point from the conductor and the total conductor, right, divided by r square, or the square of the distance of separation. Now say for example we are taking this straight conductor likewise, right, and we intend to find out the magnetic field this B over at this point, right. Now from the previous concepts, if we take up that we are taking this particular for this dl, this small part dl, now due to this dl, obviously there would be some b associated with it, right, and this same dl could be over here also. So that will, this small dl over at this region, it will generate another magnetic field. Now we shall say that the magnetic field that is being produced by this dl will be equals to dB, and after then we have to integrate that the B caused by this L plus this D plus this B, or the magnetic field caused by this L, this L, this L, this L, and likewise, right? So in this scenario, we could observe that if this is the point, we could take up that this is the distance of separation between them. Let us say, for example, the distance of separation between them is S, and the perpendicular distance of separation, or the minimum distance of separation between this point and this conductor, will obviously the perpendicular, right? So this will be 90 degree. So this will be equals to, say for example, let us take it as R, right? Because we know that the minimum distance of a point from the conductor, which means that it must have to be perpendicular on that, right? And as we know that the angle, this is GL on this side, and this is the like S for this, the distance of separation from this point to this point. So the angle will be this one. Let this one be equals to theta, and this degree, this angle, let us say it as alpha, right? So this small b at this point only produced by this GL, we can write it quantitatively as dB is equals to mu naught divided by 4 pi. As we are taking this case, the entire scenario in free space, that is the reason why the permeability we are considering is mu naught divided by 4 pi multiplied by, now there will be a current flowing through it. Let us take for example the current flows in this direction, I, right? So the amount of current flowing through it is I, so it will be I multiplied by the length of the conductor which has been taken into account is GL, sine of theta, because this is the angle between DL and this one, the distance of separation, divided by the square of the distance of separation between them. In this case, observe this is S, not R, because if it has been R, then we needed to take this DL over here. But since this DL is over here, we have to calculate the distance of separation from this point only to over here, right? So this will be S square. Now from this triangle, what we can observe is we can deduce that phi plus alpha is equals to pi by 2, because since it is a right angle triangle, this one is 90 degrees, so the other two angles, the summation must be equals to pi by 2. Or we can write theta as equals to pi by 2 minus alpha, right? So if we are going to take sine theta, it will be equal to sine of pi by 2 minus alpha, and sine of pi by 2 minus alpha, what we can write it as? We can write it as cos of alpha, right? Now again, in this scenario, if we observe, we could say that this is alpha, right? So we can write it as cos of alpha is equals to base divided by the hypotenuse, or R divided by S. This will be R divided by S. Or in other words, we can now write as that S equals to R sec alpha, right? And let us give, say for example, this is one equation that we are going to replace this sine theta by this cos alpha, okay? And this is the second equation what we got, that S over here will be equals to R sec alpha, right? Now again, from the laws of trigonometry in this triangle, we can find out that since this is GL, and if we take from this midpoint of DL to this perpendicular distance, right, where it has ended, if we take this length as L, then we can write that tan alpha will be equals to L divided by R. This is L and this is R, so the tan of alpha will be equals to L divided by R. Or else we can write that L equals to R tan alpha, right? And now if we are going, like say if we are going to differentiate this L with respect to alpha, we are sure to get dl will be equals to R sec square alpha d alpha, because the differentiation of tan theta, as we know from the laws of differentiation, that the differentiation of tan theta will be equals to sec square theta, and R has been the constant over here, because see, this R won't change with the change of alpha, right? This S, this value of S can change with the change of alpha, but the R will remain the same, right? So let us check out that this is the third equation. Now we can write this dB as equals to mu naught divided by 4 pi multiplied by I multiplied by the dl. What is dl right now? R sec square alpha d alpha. it is r sec square alpha d alpha multiplied by, now the sine theta, we can write the sine theta as cos alpha, right? Multiplied by cos alpha divided by s square. What we can write s as? R sec alpha. So s square will be equals to r square sec square alpha. Over here, r square sec square alpha. Now also over here, we can cancel out this sec square alpha with sec square alpha over here. And we can cancel out this r also as with r square, leaving only r as the denominator. So the expression will look like mu naught divided by 4 pi multiplied by I cos alpha d alpha. This is say r, right? Now we wish to find out the entire, this is dB, or the magnetic field that is being produced only by a small interval of r, only due to a very small part of L, right? This straight wire. Now we wish to find out that what would be experienced at this point due to the whole wire. So means we have to integrate it, but with respect to which boundaries? See, the upper boundary is over here, right? And the lower boundary is over here. Okay? And this angle would be, say for example, take this angle as phi 2, and this particular angle will say be equals to phi 1. So now we can see that if we are going to take phi 1 plus phi 2, that will actually mean that from this point we are covering up the entire wire. But this phi 1 is on the lower side of this perpendicular drawn on this straight wire, and this phi 2 is on the upper side. Okay, so the lower boundary we could say as minus phi 1 and the upper boundary as plus phi 2. Okay, so what we can do is that if we wish to find out the total B due to each and every small part of this wire on this point, right? So that will be B equals to the integration of this entire, because this expression was for dB, integration from minus phi 1 to phi 2. Then only we are going to find out the actual B for this point for the entire current carrying conductor, right? Now look and also mu naught 4 pi I, right? And R. Will they vary with respect to alpha? No. R won't vary, mu naught won't vary, 4 pi won't vary because they are the constants, and I is the amount of current. It actually won't vary that whether you are going to keep this point or this point, right? So we can write it as B equals to mu naught I divided by 4 pi, and this will be over here as R, integration from minus phi 1 to phi 2 of cos alpha d alpha. And as we know that the integration of cos theta with respect to theta, it gives simply equals to sine theta. So we can write this expression as equals to mu naught I divided by 4 pi R multiplied by sine alpha integrated from minus phi 1 to phi 2 which will come out to be as mu naught I divided by 4 pi r multiplied by sine of phi 2 minus sine of minus phi 1. And from trigonometry we know what? That sine of minus theta is equals to minus sine theta. So we can write the expression of B as mu naught I divided by 4 pi r multiplied by sine of phi 2, and this will be minus sine phi. So the minus and minus, it will make the multiplication as positive. So plus sine of phi 1. So this is the expression for the magnetic field which is experienced at a particular point over here, separated by a distance of r. This is r, the perpendicular, the shortest distance. Now this is, where is dl? There is no dl. Why? Because over here, if the length shortens up, this phi 2 and phi 1 will also shorten up. If the length increases, this phi 2 and phi 1, they will also increase. And that is being indicated over here as sine phi 2 plus sine phi 1. So this is the expression for the actual magnetic field which is experienced by this point due to a straight conductor. Now let us check that this straight conductor is infinite. It is infinitely long. So, which means that it is extended till infinity on this upper side as well as the lower side. In that scenario, the phi 2, if this L, because this entire L, the length, is infinitely long, then we can say that the phi 1 is equals to pi by 2, because it is infinitely long over here. This will say, for example, 30 degree, then it will increase to 45 degree, then it will increase to 60 degree, then 75 degree, like this, as you increase on this direction. And if you increase like infinity, it will seem as if it is 90 degree, right, or pi by 2. And likewise, the same applies for phi 2. The phi 2, it is equals to again pi by 2. Now let us apply this value of phi 1 and phi 2 in this equation, and we are going to get the, say, B over here due to infinitely long straight wire as equals to mu naught I divided by 4 pi r multiplied by sine of phi 2 plus sine of phi 1, means sine of pi by 2 plus sine of pi by 2, which means 2 multiplied by sine of pi by 2. And from trigonometry we know that the value of sine pi by 2 is equals to 1. So it will be 1 plus 1, that is equals to 2. So we can write it as mu naught I divided by 4 pi r multiplied by 2. And we could cancel out this 2 with 4, leaving only 2 on the denominator side. So we can write for this case as B for infinitely long wire as equals to mu naught I divided by 2 pi r. This is mu naught I divided by 2 pi r, right? And this is the scenario only when this wire is infinitely long. Right? So in this particular lecture we have discussed that how to find out the value of V at a given point for an infinitely straight long wire, checking as dl over dl and then integrating. Like dl for dl we will finding out dB and then integrating over the whole dl will give us the total length, which means that integration of this dB will actually give us the total like B. So we need to integrate it from the entire length for the entire length, and we are going to find out the value of V as mu naught I divided by 4 pi r multiplied by the sine of this angle plus sine of this angle, upper side whole angle and the lower side whole angle, right? And afterwards we have seen that if L is infinitely large, then the value of B at this particular point will be equals to mu naught I divided by 2 pi r, right? Thank you.